Welcome back to Physics with Miyoshi. Today we're going to talk a little bit about, I'm going to do a problem about Newton's second law. And in this problem we have an airplane with a pilot in it, and we're going to try to find out what the force is on the pilot himself or herself. And the way we're going to do that is figure out what the acceleration is. And the reason we can do that is because we can consider the pilot and the plane a system, and consider its total mass and its total force, and then figure out what force is being applied to that pilot all by himself. Now, if we think about this, the total force cannot be applied to the pilot, otherwise the pilot will go at a much higher rate of acceleration, and we know that the thing that's the same with these guys is that they are both accelerating at the same rate. So, the way we do this is we know what the force is. We draw a free body diagram, and you don't have to make such a beautiful picture as mine, but we put the force behind it, and the force total is 3.7 times 10 to the fourth newtons, and our mass total is 3.1 times 10 to the fourth kilograms. We know that the mass of the pilot is also 78 kilograms. So let's find out what the force really is. There's two different ways to do it, and I'm going to show you both. The first way, we're going to find the acceleration first, and really we can ignore the vector nature of the force and acceleration because we know they're going in the same direction, so we'll just get rid of that guy there. And we know that the acceleration is sum of our forces divided by our mass from Newton's second law up there. And then, so that's going to be our force total divided by our mass total. That will be 3.7 times 10 to the fourth newtons divided by 3.1 times 10 to the fourth kilograms, which gives us 1.19 meter per second squared. Okay, because remember, a newton is a kilogram meter per second squared. Then we're going to just find the force on the pilot by multiplying our mass of the pilot times our same acceleration, because we know that they're accelerating at the same rate. So then we're going to multiply that 78 kilograms times our 1.19 meter per second squared and get 93.1 newtons. Now, if you like proportions and ratios, you can merely remember that our acceleration is going to be constant. So, or it's going to be the same for both the pilot and for the whole plane. And we can look at acceleration as our force of total divided by our mass total, which is also equal to our force on the pilot divided by our mass of the pilot. Then we can just get rid of that, and then we have a proportion there. We can solve that proportion by solving for our force of the pilot on the pilot. And the force of the pilot is our mass of the pilot times our force total divided by our mass total, which again, from over here, is just our acceleration. And we know that from here too. Then we can just put this all together. 78 kilograms times 3.7 times 10 to the fourth newtons divided by 3.1 times 10 to the fourth kilograms. Our kilograms is going to cancel out there or divide out, and we're going to be left with 93.1 newtons, which is exactly the same, because as you can see, it's exactly the same calculation as we did before, with one little step less. But this is an application of our math, our proportions in math, and you can see that because we do have the same acceleration. And that is the key to this whole thing, recognizing that our pilot and plane act as one mass, and therefore they must have the same acceleration. And that is the key to this whole problem, realizing that the acceleration is the same. So, a fairly simple problem about Newton's second law and how to demonstrate that. So, thanks for tuning in, and hopefully see you back again for more Physics with Miyoshi. Thanks a lot.